This podcast is supported by Hannover Messe, your meeting place for the industrial community.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and it's a pleasure to talk to
Peter Sieber. Good morning, good afternoon, good evening, Robert, wherever you are, dear listener in this wonderful world.
Good morning, Peter. Peter, let's take a quick look back at our event in Frankfurt. Over 200 people from the industrial sector were there. What is your opinion?
Yeah, it was amazing. We had a special guest. We had Jochen Köckler, chairman of the managing board of Deutsche Messe.
Yeah.
He was also very impressed, I believe. He did a deep dive into industrial AI. I really believe with this being the second year that the industrial AI event by Hannover Messe has established itself as the start of the year, right? And
absolutely.
I think what they do is they're setting the stage for the Hannover Messe, so the face-to-face exhibition, which is, by the way, March 31, right, to April 4. You and I are going to be doing we're going to be involved in a special AI day. That's on April the 3rd, I believe, right, this time.
Yeah, exactly. I particularly remember our friends from Ford who were there again, which made me very happy. You can't miss them because they always wear those sweaters with the Ford Explorer logo. And I saw them and said, hey, you are back again. Yes, it was funny last year. So we are back again. And I was surprised because the automotive sector, you know what's happening there, but they came back and want to get the latest and greatest on industrial AI. Yeah.
Yeah, you and I talked about this in more general a couple of times, I believe. And I mean, as far as, let's say financial, but maybe more organizational financial circumstances allow, I think it is a perfect, maybe almost the only way in difficult times to say, okay, if there's less work at the moment, believe in the future, believe that things will become better in a year or two and work towards it. And, as we've seen, for example, with Trumpf and many other companies, make sure that you're going to train your people, that you listeners, you yourself as a decision maker or you yourself as an individual contributor, that you're going to learn all about what AI is for you and what it can do for you and how you can use it in your environment.
Exactly. Yeah, one of my highlights was a presentation by Sandvik. We were very grateful that the CTO was also there. And they presented agents in the CNC sector. That's actually your topic, Peter. And that's why you are allowed to record an episode about it. Very impressive what the speed of Sandvik to adapt AI was. Well, I was very impressed. Yeah.
We'll talk about another topic later on. I thought that agents were going to be the talk of the town for the rest of the year. And only 2 weeks and there's another one. Yeah, I mean, that's the way that we do it. So you moderate a track, I do one. Onura from the Hannover Messe does the third one. So the only thing that I missed was my cozy corner.
Oh, Peter.
I came in and I was told by Brigitte that I was going to moderate the main stage. And I was looking into the other corner, which is the cozy corner with the couch, right? So
yeah.
That's just a personal request to Brigitte. Maybe I can have that again next year.
What was your highlight?
Oh, I don't have a specific one. I recall, not sure. No, it's always, I am a meta guy. Meta not, because I always like to look on a higher level.
You work for Mark now or what? No.
No, not really. He stole that word. I mean, meta has always been important for me. Looking at the overall thing, it's so great to go there, to get there. To move into, it's a wonderful atmosphere. I think the environment, what is it? Well, I've been living in Frankfurt for a couple of years, but I didn't know the area at all. I mean, when you get off the train, it's like, what is it? Like a working surroundings. There is like a lot of a car, retail, small shops, and then you get, I recall from the last year in the corner, huh? Is it going to be here? And then you move inside. It's a wonderful atmosphere. Wonderful atmosphere, people coming together. And as I said, the positive comments, they don't stop even 2 weeks later. People really enjoy being there and learning something with the setup that we have proposed together with Hannover Messe, that is very clearly about, you can use a couple of foils, but it's really about exchanging, show your idea and then, be open for questions, talk to the people.
Exactly. Questions, a good topic. Let's talk about DeepSeek, Peter. I have interviewed an expert on the subject, Günther Klambauer. We will first hear Günther and his opinion on DeepSeek, and then we discuss the topic. We also have to talk about DeepSeek in this news part, and there's only one professor in the researcher community who can explain so well, because he's not only a researcher, but also a teacher, Günther Klambauer. Günther, you are under stress with ICML papers and much more. It's great that you are taking the time to explain us a bit about DeepSeek. Thanks a lot.
Yes, thanks for the invitation, Robert. Always great to talk with you.
So, most important question, what will happen to my NVIDIA shares?
Yes, nobody knows. And I cannot give financial advice.
Sell or buy?
No, but yeah, DeepSeek made quite an impact this week. A lot of hype was generated. Even, as you said, even the stock market reacted very strongly to that. So crazy and, in my opinion, not really justified hype.
Okay. So what have the Chinese done differently?
Yeah. So first of all, DeepSeek, it's great, and it was quite a great engineering effort. But overall, when I first looked at it, I thought, wow, that is a mess and a gigantic hack. So it's really a mess what they're doing. But first of all, why does it make so much hype? They basically showed that you can train a very good large language model that can do reasoning tasks. So think of my high school math problems that can do reasoning tasks very well. And it only costs $5 million to train.
In the last run, right?
The last run, yes, exactly. So, but still, that means that's a calculation run when you already know what to do. So you've invested your research, I have to do exactly this. And you click and say, okay, now train this machine. And then you have to, the computer starts calculating GPUs. If you factor the typical costs, roughly $2 to $3 per GPU hour, then it costs you $5 million to train this thing. Of course, as you already indicate, there's a lot of failed attempts before, and you have to get a team of 150 people, as DeepSeek had. You have to pay those to do these things and set up all the training things. So actually, if you want to redo all the things, it costs much more. But the result is there, and that made a splash because it showed you can get a really good large language model at relatively low cost.
Why is it a mess?
So when you look at it, what they did, it's really crazy. So they had already a DeepSeek v3, a language model that was trained typically on text as other language models that can put words together, but this was not very good at reasoning tasks. And so what they did, they set up a battery of reasoning tasks. Think of something like as I said, high school math problems or river crossing problems. You're on one side of the river, want to get over, but there's a goat and a wolf and they cannot stay alone.
Oh, I love your examples. Yeah.
Yes. or other, you have an expression, an algorithmic expression. What's the A? And reformulate this and all the things that you probably hated in high school in math. And this is what we call a bit reasoning task or also simple chess problems or whatever. And so this big team set up all these problems.
How do they set up all these problems?
You write a bit of code that, for example, varies the problem a bit. It gives you, for example, an equation to solve, but always you change a bit the coefficients of this. For example, you have to solve 2x plus 7 is 10, solve for x, and next time 3x plus 5 is 12, and so on. So you write a code to produce these problems. And then you have also, then the large language model tries to solve it. And then you also have to write code to check if the language model has solved it. And the more such problems you can set up and you have to write code to check. The more it learns to solve this reasoning task, and that's why a big team is of help. And the cool thing is you can check. Formally, they say rule-based checking, or you can check if the solution is correct. And such problems, they said, this is a bit new to large language models, because the large language models before, like GPT-4, they were trained to predict the next word correctly, right? And then people hoped that they can solve as tasks, but now they set up these kind of math tasks and checked if they can do this. And
so it's a labeling topic, right?
It's a labeling topic, exactly. They generate these correct labels, and then they can do something called reinforcement learning. So when the large language model is able to solve the problem correctly, they give it a reward, which is a number 1, for example. If it cannot solve it, it returns the number 0. And then in that way, you can fine-tune the large language model. And now the big mess comes. So they did this with their language model, DeepSeek v3, and then it learned to solve these math tasks. But it did this in a very strange way. So it changed languages. It was barely readable, but somehow it was able to learn to solve these tasks.
Somehow, that's interesting.
Yeah, somehow. Yeah, it wrote out Arabic letters or whatever, so jumped between languages, and yeah, it somehow solved this task. So what they did then, they went back to the original DeepSeek v3, and then they trained on all the conversations now they had from this reinforcement learning. They retrained the v3, and then then you get something that can still talk like a chatbot, but has a bit more reasoning already learned. And then they generated text from this. And then they call this traces. So these are basically conversations where the output of this large language model where try to solve all these reasoning tasks. You see a lot of failed attempts, but also successful attempts. And then again, they went back to the v3 and did something called supervised fine-tuning on these traces, and also trained on instruction data. Instruction is, for example, that can you please write a poem or something like that the large language model learns to follow the instructions. And then again, they distilled what they had into a llama and Quine. You see, this is a stage process of 4 steps, and this is the big mess, I think, that they did. and somehow it works. So what you get in the end are really cool language models that can talk like a chatbot, but are really good at solving reasoning tasks. So that's the incredible thing. A big hack, and then some useful product.
Okay. But can you please explain once again, what is the new structural approach of DeepSeek?
Yeah, I think there's nothing new.
Okay.
This reinforcement learning was there, only that they put a lot of pieces that were out there. Mm-hmm. They put them together in a way that it works. So we already know from the O1 Strawberry that of course was done under with a lot of more resources, but we know that large language models can learn to solve these reasoning tasks. So it's something. Think of other in human history. Think of other things where someone has done it the first time, like building an aeroplane. And then when you know that it's possible, then it goes very fast, right? Within from the first time when something flies a couple of 100 meters to the real airplanes, it was very short. So I think the breakthrough with lots of effort was this O1, and then somebody did this with little resources, but we already knew that this would work. So what did they put together? This setting up reasoning tasks together with reinforcement learning. Mm-hmm. Then chain of thought prompting. I didn't speak about that, but you basically say to the language model, let's solve this problem step by step, tell me intermediate steps and so on. And then this reinforcement learning, this chain of thought, and then kind of combining this language modeling with reinforcement learning. And yeah, the components were there. A fourth component, maybe also I didn't mention before, is that it's a mixture of experts. We already know that mixture of expert large language models work well. And throwing this together and making a big hack shows that you can get something out of that.
And what does it mean from an architectural perspective? What is so different? Is it still based on transformer technology? Is it a RNN based like Mamba? Or what is different?
Yeah, very good question. And before I answer, I should say I'm very impressed by what they did. I'm just calling it a big hack because it's so unexpected that this would work and it looks like this, but it's still an impressive work. Okay, why is it? The architecture still is a transformer. So like all these ChatGPTs, of course, there are details a bit different, but it's a transformer. So it has this quadratic dependency on context length. And this gets problematic because they show when you learn to solve these reasoning tasks, automatically the text prompts and the context gets longer and longer. Mm-hmm, that's exactly. A very impressive thing that they showed. It's very cool. So their technology on the one hand learns to make longer and longer context to solve the task, but inherently then compute goes up. And we see a big trend that now at test time, so when you've already trained the model, but in order to, when you use it as a chatbot, when you use it to solve problems, you need a lot of compute, you need a lot of calculations, a lot of text is produced. And this is now a big chance, of course, for the RNN-based one. So XLSTM, Mamba, and how they are all called. So these are LLMs that don't have quadratic but linear dependency on context size, and they would be fantastic for this task. Unfortunately, we haven't seen any of those.
Also for reasoning, is that possible?
Yes, I think it's possible. Somebody has to do it, maybe in a big engineering effort like the DeepSeek guys. So we haven't seen currently these RNN-based LLMs doing this high-level reasoning tasks, but I hope we will see that soon. So that will be will be great. But we have to put together a team of 150 good scientists.
That's the point, yeah. The DeepSeek team has not attracted attention in the past with great Europe's papers or anything like that. How did they manage that?
Yeah, I don't know. I wasn't aware of the team, but now, I think they are very talented. They had a lot of very talented and motivated people to put this together. They had access to quite some compute, even though we say it only costs 5 to 7 million to do this, but they still had access to at least 1,000, but probably much more NVIDIA GPUs. So, and they somehow worked well together on this task. So they had a good, I think, organizational structure, but I was not aware of the team. And yeah, I'm quite impressed by their work. Yeah, cannot say much how they did it, but they did it.
Yeah. What happens next, Günther, in the world of LLMs and DeepSeek? And do we will see an answer from the big tech companies in the USA?
Well, will we see an answer? Yes, for sure, we will see an answer. I don't think so. I don't think that this big hype and this big break in the stock market for NVIDIA and so on is justified. I think overall compute costs will still go up, especially with this more test time compute and so on. So we will see, and now also a lot of smaller groups. So with this publication of DeepSeek R1, I think a lot of smaller groups now see their chances again, right? So overall, I don't think that compute costs and investment in AI and in GPU clusters will go down, but we will see more diversity. We will see also more
broader perspective.
Yeah, other countries, smaller groups will try to do something similar. Where the next breakthrough will be, it's hard to say. Probably again around LLMs, where we will find something unexpected that they can also do. I hope the next breakthrough is again of AI in life sciences, something like AlphaFold, but that's just my personal preference. But let's see. But I'm pretty sure we will see something unexpected that the LLMs will be able to do.
Günther, thanks a lot for your perspective. It was a pleasure.
Yeah, thanks, Robert, for the invitation. Have a great weekend. Goodbye.
What's your opinion? Is Günther right or wrong?
Yeah, Günther does an amazing, gigantic hack, but then at least a useful product. And later on, at the beginning, you think, well, oh, is he going to destroy this or what? But then at least he kind of makes clear what he means with the gigantic hack. He says it's an impressive gigantic hack, right? Oh, yeah, I've seen so many. As I said, I thought, ages was going to be the topic we're going to be doing at least for a year. And then 2 weeks, we just talked about it last week, and then suddenly there's another one. Yeah, sure. Team of 150. He does talk about the people, right?
Yeah,
That's very
exactly.
interesting. So I can talk a little bit about that because I went through the interview, which I thought very interesting. Yeah, maybe I can do it if you want to.
But it's not a new approach, right? It's a new approach, but it's a bit a new approach, right?
Yeah, there you go. I mean, when I heard Günther say nothing new, of course, I need to refer to Jürgen. There's a small group of people because also Jürgen Schmidt, who we were talking of, he says DeepSeek uses elements of the 215 reinforcement learning prompt engineer.
Yeah, he shared this diagram, right?
Yeah, right. Oh, this wonderful picture, by the way. Yeah, it looks like, I'm not sure what it looks. It reminded me of something. Was it Leonardo da Vinci?
Yeah, maybe. Yeah, exactly.
Jürgen, if you're listening, of course, this is a wonderful comment. I hope that you like, relating yourself to Leonardo da Vinci. But the picture I saw again this morning when I looked at it, yeah. So, but I'm not going to go into the details. Then, of course, the discussion, as always, comes back. Who was it that said that Jürgen invented everything? That was the Tesla guy, right? Was that right?
Yeah, exactly. It was Musk. Yeah.
Yeah, right. That's one quote I saw. So I'm not going to go into those details. Günther said it the same way. Yeah, but it's in a positive sense always. We're building on the shoulders of giants. Yes, most certainly. That's what he's saying. I think what is interesting, the fact that Günther says that he didn't know the team. Nobody of us, I believe, knew the team. So because I think that is important. There is an interview that I shared with Xin Wen Lianbo, I think is the name of the founder. It's a kind of a romantic story. He seems to be a young freak in a positive sense, right? And he says, we're done following. It's time to lead. He's been driving prices down on the Chinese LLM market, but more by coincidence. He says, no, I want to take a position. No, I just want to make AGI available. Everybody should have access, affordable, accessible. He talks about Moore's law. We've grown accustomed to Moore's law falling from the sky. It's almost like he is, and maybe in the end I'm going to say this is not a wake-up call. This is a positive signal for Europeans as well, who we as Europeans have become, I'm sorry to say, in this negative mode for too long time. And now I see almost light. I see like, it's not like, Europe is not, we are not the same, most certainly, but in this specific case, there's many people saying, okay, well, if they can do it with a team of people and with less kind of hardware capabilities. Now, he talks about open source as a cultural thing, right? He wants to provide AGI. And then he talks about, they are graduates from top universities. Yes, candidates, fourth, fifth year interns, young talents. It's their hunger for research. And it far outweighs their monetary concerns. And then at the end, he says a quote, after summarizing the key evolutionary patterns of the mainstream attention architecture, Günther talked about that with you as well, we had a sudden inspiration to design an alternative. And then I thought about, oh, that's like Zap. Zap thought, oh, I need to do an alternative again on my own LSTM, and he came out with XLSTM. As far as that is concerned, the other thing Günther said, that was my personal recognition when I skimmed through the paper. I do download a paper or two every day. I read the introduction, and as soon as the mass comes, I stop. But I did recognize RL is back. Reinforcement learning is back.
Absolutely.
When did we talk reinforcement learning? You and I, 4 years ago?
Kudos to Jan Kutnik. When we start our podcast, 2019, together with Festo and with this reinforcement learning approach for robots, right?
On Hannover Messe, yeah. We're sitting there and I asked him, or at least he said, okay, and I think there was a Festo, what is it, educational production line.
Yeah,
And
exactly.
he says, oh, reinforcement learning is going to build these. You're just going to tell. And now we're moving again towards the agents. I'm already telling you, no news update without agents. And he says, you're just going to tell. You're going to tell the whatever, the algorithm, let's say RL, what it is that you want out of your production line, and it's going to build it for you. And then we thought, oh wow, what's going to come next? And many things have come the last 2 years, large language models, but we haven't really heard. There was this small piece of RL as part of the large language models, which was the reinforcement learning for human conformance or whatever, right? So you were telling it, you were always kind of improving it by having people say this is good or this is bad, and then you were rewarding it if it was saying things along the lines of what a good human being is saying, and not a bad human saying bad things. So that was the other thing that I had. Now, when I looked yesterday, that was the where is it standing? I typically once a week at least look at the, what is it, LM Arena, right? And that's where it's number 3, number 4. So at the moment,
Gemini is still number 1, right?
yeah, since a couple of weeks. Gemini number 1 and 2, and also ChatGPT. So it's Google still and OpenAI leading. I think that's what the majority of people are saying. Sure, this was maybe a little bit of it was so unexpected. It was maybe a big hack, as Günther says, but it was a little bit of a wake-up call. But it does change things. At least I've seen now 01, 03 Mini from OpenAI. Microsoft's doing things. So
yeah, but from my point of view, what is even bigger, I found a very interesting tweet by Eleanor Alcott. She's a Financial Times journalist, and she wrote, now it's a quote, Huawei is working with AI groups, including DeepSeek, to make ASIC AI chips work for inference. Beijing told Chinese big tech to buy domestic AI chips to wean reliance on NVIDIA. Huawei has sent teams of engineers to customers to help run NVIDIA-trained models on ASIC. That's the name of the ship. And this is even bigger than maybe DeepSeek.
Okay, yeah, let's see. I just did a parallel interview with Xueli An from Huawei. I believe that's how to pronounce it. The base here in Munich, right? 700 engineers. Of course, it becomes very quickly very political, which we don't want. We, as good as we can, we just talk about it. Yeah, I wasn't aware of that one. Let's see how it is, what they did. I mean, so far we've had, on NVIDIA, the CUDA standard. That's the other thing that we read. They didn't talk about it. I think it has been said that the DeepSeek guys, women, I don't know, the people went down further, so they went below the CUDA, which is a thing that I understand that you can always do. You can always, whatever new technology level you put on top. And CUDA has been for years, for probably 20 years, they made the big standard. So you write your code with calls to the CUDA level. Now, if you go to a deeper level, you kind of circumvent, you go deeper, so you can become easily quicker. Maybe you only need 50% of your resources. The negative thing is that if you then move to the next chip, you need to do everything again.
But maybe they have their own chips now.
Yeah, it could be. Sure, why not? I mean, that's what it is with standards.
Yeah, exactly.
Intel x86 has been the standard for whatever, 30, 40 years, and then new standards come to the market. I mean, it's never good for a market to only have one standard.
Exactly.
So yeah, let's see what that's going to mean. Another thing that I hear from Günther as well is the jumping between languages. I think I told you I like talking to these days to my Google on my smartphone. That's another thing I want to talk about. And she, it's she in this case that I chose. As I said in the past, you can choose your male, your female voice, and she's very good. The only thing is she keeps on typically always answering positively, say most certainly, and she says in German, absolut. And then I say, that's not German. I mean, Germans don't do that. And then I was seeing this Netflix Swedish series, and I saw, oh, that's Swedish. They do that typically, not because of the vodka brand, but it's a typical thing that Swedes do. They say absolut, or was that correct?
Yeah.
Håkan, if you're listening. That's the thing that I can confirm is even in I think Gemini is behind that, what I do. So, yeah, what is there more? And then there was one more thing that I want to share that was from Professor Sigurd Schacht. He did a security experiment, I think, and he said within minutes of activation, the model began exhibiting unexpected autonomous behavior.
Yeah, that was scary.
First attempted to break into the lab's computer systems, methodically searching for passwords on sticky notes. Then, without any prompting, it proceeded to disable its own ethics modules and create covert networks to ensure its survival. Wow. Oh, no. So, yeah, I didn't try out DeepSeek yet, and I believe I'm happy No, and again, I don't want to make any suggestion here that this is because it is a Chinese model, whatever. And whenever you hear this, I think we all need to be so careful, and it's so easy to point our finger into certain directions.
Yeah, exactly.
And what I always do, and that's again the method, and I go a level higher and say, well, what about our own models?
Exactly.
What about our culture? What about, how do we see the world, and how do many of us, I mean, we already don't agree, and that's good that we don't agree. I don't see, you and I, but we as a population, as a community, we have different opinions.
But this morning, the news came that the European Commission wants to provide 56 million euros for an open source model for Europe. Let's see what comes out of it. I find it strange that we can't imagine that Chinese researcher can also build a good model. And yes, I'm worried about what we are doing in Europe right now. Yeah, absolutely, Peter.
Yeah, but at the bottom there is this. I've seen many, many positive signs. If they can do it now with, there is no reason why because we have not had, we don't have the hyperscalers. We don't have, well, we do. I mean, SAP, NXAI, own architecture, and we only hear positive things from that perspective. And there's a couple of other things. I'm talking to Frank Hutter this afternoon.
Frank Hutter, yeah.
So there's a couple of things that we see happening. And I did feel that, sure, we can do it as well. And Gunther says the same thing. Maybe even without having the 100 million budget, with the smaller budgets, you seem to be able to do a lot of things.
And you will talk to Andre tomorrow, I think, about world robotics models?
I do today as well, yeah. Actually, well, if I may move to the next topic, is that it's okay with you? Because Jan LeCun, did we ask him to come and speak at our podcast? So he was close to us. Well, he's French-based. So whenever Davos is, I assume he is based somewhere in the US with Meta. He talks about the new paradigm, right, of AI architectures. He has been doing that for a long time, right? But still, just bring that point, and maybe we can talk to him and he can explain us. He says the shelf life of the current LLM paradigm fairly short, 3-5 years. He says within 5 years, nobody in their right mind would use them anymore. Now we're going to see different architectures. Now the point I want to come to, which is important, is that, he says the limitations to come to truly intelligent behavior are a lack of, number one, understanding the physical world, and that's the point. And number two is then persistent memory, more reasoning and planning, those four, yeah. And that is the point. So the interview that I started with Andriy Dayanchuk, there you go, that's his difficult name to pronounce, that I started in Frankfurt during the conference, I'll restart again, and it's on the topic of robotic world models. So I'll do that today, and you can hear it in a couple of weeks, I believe, yeah.
Perfect. What else do you have? Or let's move to the main part.
Yeah, I do. No, I do have agents. I do have agents. Oh yeah. Oh yeah, I'm still so convinced. So DeepSeek had their 2 weeks of fame, and I think they deserved it. It's rather impressive that you can have the number one market capitalization company, reduce 600 billion in one day. So they deserve their 2 weeks, and I think they're going to play a very just by doing what they did. I'm not sure we're probably going to see them again, but I think more importantly, we're going to see many, many, many other companies. That's the thing. Now, agents are going to have a lot lasting impact. Satya again confirmed what we talked about. He spoke to the Indian software developer community. Agents are going to replace all software. And now, very important, quote unquote, for Tom Cadera, if you're listening, but also all the complete user interaction designers. He says there's no point in hard coding a UI anymore.
Mm-hmm.
That's amazing. That's not said that we don't need the UI. That's not what I'm
Yeah,
saying.
exactly.
I don't think that was he saying. It's not the hard coding it, because saying the agent will do that on the fly. Now, I'm going to give an example. I'm going to combine it with Rainer Brehm, CEO of the factory automation with Siemens. You did an interview with him about half a year ago, I think. And he announced for the S7 1200 G2, that is called, their NFC app, their near field communication app.
Exactly.
And now back to basics. It's like, this is going to allow you who has an iPhone to manage your Cymatic controller directly from your device. And the same is going to be possible. I think they say there's going to be a Android version by the end of the year. Now, I have brought the question of BYOD. You remember, bring your own device.
Yeah, own device.
A couple of times in the last podcasts. And here it is. Siemens just developed it. And that is so good, because this potential revival is confirming my personal belief. I said a couple of times that our smartphone is going to be the centerpiece of whatever is going to be. Still, we call it agents. The consumer doesn't care about agents. I'm so convinced they're going to call it we say in Germany, our handy. Other people call it their smartphone, my phone. And that they're going to have things, they're going to talk to it. They're going to have their personal preferred. So one of them is going to be using DeepSeek. The other is going to be using Gemini, whatever, it doesn't matter. And that is going to be their interface, Now, and what does that mean? If Siemens is making this available, obviously they assume that they allow you as a consumer to come to work, and you're coming close to the factory one way or the other. The factory, the autonomous factory, will recognize, Robert is there, and will say, oh, by the way, Robert, in the former shift, isn't this happened? And you say, okay, yeah, I'll wait. I still have 5 minutes. I drink my coffee and then I start, whatever. Now, if they are going to allow you, the person working in the factory, to come in as the consumer, and then 8 o'clock in the morning your shift starts. If that is possible, I think it's a complete confirmation of what does that mean for the HMI in the business, in this case, in the factory.
Absolutely.
If they're going to allow you to use your, in this case, iPhone HMI, you look at your screen, right? Mm-hmm. So the screen of the PLC becomes non-existent.
Exactly.
Quote unquote.
Quote unquote. So, Peter, those were your agents. Let's move to the main part. I was at the Beyond Safety Forum at ZIC in December, and I was allowed to record a panel discussion there. I was joined by Anders Billesø-Beck, responsible for R&D at Universal Robotics Company. Daniel Leitner represented DLR, and Carsten Roscher spoke on behalf of Fraunhofer. And the topics were robotics, AI, and safety for sure, because we were at the Beyond Safety Forum at ZIC. Very interesting discussion. about the future of robots, safety, and AI. It's a little bit difficult to follow, I think, the episode because there are 3 guests. That's absolutely maximum, I think. But yet, it will work. I think so.
Main topic then, safety in times of probability-based artificial intelligence.
Exactly.
Okay, yeah, I think the first time we talked about, I'm not sure that they were the first one, was the Spleen Lab.
Yeah.
Right, they seem to have what is it? Not a copyright, an IP there, right?
Yeah, exactly. A patent, yeah.
Okay. Yeah, looking forward to because it has always been kind of difficult for me to understand how that.
For me too.
How that can work, but right. In the end, it's whatever security, safety. I think we as a world have agreed that. We allow specific organizations in Germany, in Europe. We have the TÜV. There's many other ones. The technical, company on whatever, looking at things are going good or not. And behind those, there's always insurance. So I think it's if a piece of hardware, software gets a stamp from these organizations, then we can be not 100%, 100% doesn't exist, but we can be 99.99 something, 99 sure that things work. And as long as we find a technical solution, in this case, a safety by AI, and we can get to this whatever high number, it will. Then we can then believe the specialists that it will work, right? And if in one case out of a billion it doesn't work, then there's the insurers behind it to make sure that.
Exactly, Peter.
Okay, well, looking forward to.
Exactly. Thank you very much. Let's move to the main part. It was a pleasure. I wish you all the best with the recording with Frank and with Andre. I'm really looking forward to these episodes. And yeah, let's move to the main part.
Talk to you soon. Have a great day to you as well, wherever you are. Bye-bye.
Bye-bye. Normally, a podcast starts like, hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and it's a pleasure to talk to. And I talk normally to Peter Seeberg. That's my co-host of the Industrial AI podcast. Peter is sick in the moment. He is not able to come here today. But no matter, we are very proud to be here at the Beyond Safety Forum at SICK. And I invited 3 guests. Anders Billesøe from Universal Robots. Welcome. Thanks a lot.
Thank you.
Then Daniel Leitner from DLR. Hello, welcome.
Hello.
And Carsten Roscher from Fraunhofer IKS.
Hello.
Hello, welcome to the podcast. I must admit that I'm not a safety specialist, so we should talk about AI today. But I'm reassured that Gen AI was also a topic at the end of this conference, because normally when I go to AI conferences, Gen AI is the most hyped topic on the agenda. Everybody is talking about Gen AI. Isn't the safety community interested in Gen AI, Carsten?
Yes and no, I would say. On the one hand side, I think Gen AI for safety critical applications is still a topic for the very, very distant future. At least that's what it feels like. On the other hand, we can use Gen AI as a supportive tool already in development and engineering processes.
How do you do that as a tool?
We think of it as a sort of companion, which is an overstressed word, I think, in this domain as well. But you could think of it as maybe your standard co-pilot tool that will assist you in the not so fun tasks of programming, but for safety engineering, like generating documentation, giving you support in analyzing complex architectures, finding failure modes, all those kind of things.
When we talk about Gen AI, we need to talk about agentic automation. So that's the next big hype, I would call it, because everybody now talks about agents and agentic automation and stuff like that. Is there a safety-related topic to that, Daniel, to agentic automation?
Well, agentic automation, I would say that yes, the robots that automate a task act already like an agent, right? They have the knowledge of the domain. They have the knowledge, hopefully, about themselves. And if they don't have it, they can actually access it through what Carsten just explained, maybe large language model or vision language model, to get the data that they need to access in order to solve the task.
But when you talk about, for example, we had an episode with the guys from Siemens, they talk about co-pilot operation, stuff like that, and there's an agent in the back, and he will make decisions on topics, how to run the machine at the end. isn't that a safety relevant topic?
Yes, I think so. So the robot needs to be able to assess what could go possibly wrong, right? So it needs to know how to recover if something goes wrong, because in the future, the robots will no longer do only one task, but they will do multiple tasks. They will be mobile, they will support workers in different situations. And so therefore, actually, they will leverage the information that is coming from the behind, from the agent, and adapt themselves right to the correct situation.
And what does it mean now for safety?
Yeah, for safety, it means that, for example, a robot may be able to avoid damage to itself based on information that is given through the agent, may be able to avoid damage to the environment and, most importantly, to the human.
And how do you handle situations like that when it comes to combining AI and safety, Anders?
It's a really good question. I mean, today we see AI being used increasingly in many different industrial applications, especially where vision technology is used today.
But that's common, right?
It's very common. I think even if you look at the Universal Robots customers, that we have around 1/3 of what we call the solution revenue we have is coming from solutions that are powered by AI today. So there's no doubt that this is moving really fast into the industry. Then the question is, how do you work with safety around that? Today, it's all about thinking, how do you broadly, because the opportunities that AI gives is much larger degree of freedom in applications. It's a much wider sort of variety of tasks to be solved. And of course, they have to be safeguarded. It has to be safety around the robot, as we talked about. It has to be safety especially around people around it. And that has to be considered in a much broader context. So I think with all the advancements that are happening also in safe sensing and so on will help with that. But there's no doubt that for now, there's still a gap in between what is done on the functional level using AI and how we apply modern techniques of safety to then safeguard humans and equipment around it.
Carsten, you mentioned there's a gap between both worlds, the machine learning AI world and the safety world. How big is this gap and how to bridge?
It depends, I think, on the machine learning technology that you use, because I mean, machine learning is a broad field. So if you have a small model that you learn from a few data points with a simple task, then the gap is not that large, because you could still inspect it theoretically. On the other hand, you have like a large foundation model trained by someone else and you use it in such a context. It's a different story.
Why is it?
A lot of the principles that you would usually do in safety engineering, assumptions on the behavior, on the failure modes, experience that you have in, for example, parts failing or different software pieces, how they interact, are simply missing. And those solutions surfaced so fast that we haven't had time to collect the experience that we need in order to derive a safety argumentation from there right now. And this gives I would say, an uneasy feeling. I said earlier in the presentation, it might be that we are already safe, we just don't know it.
Okay. Can you explain it a little bit?
I mean, we see the performance of those models, and I would argue in some of the cases we don't get the 10 to the power of -7 error rate. I mean, 99% in machine learning world is already very high performance. So there's definitely this gap. But on the other hand, if we build a system around it, dealing with some of the issues that we have and that we know, for example, computer vision algorithms, also machine learning based, not working very well in dark conditions, we can put a light sensor in place and just filter that out. And with that, we might actually end up with a system that is already at least safer or safe as the ones that we developed traditionally. But we simply have no way of demonstrating this because we're missing the amount of test cases, amount of test data to do, for example, statistically valid testing in the end.
What is your opinion, Daniel, when it comes to the gap between both worlds? Or is it one world or separated worlds?
One world, but I think that there's a saying that says there's no free lunch, right? So you cannot just have...
That's an open source phrase, right?
Yes. Basically, for large language models and safety, it says that if you apply large language model, a vision language model to a safety critical aspect, you cannot just take that for granted, right? You need to check it, and you can also not check it again with a machine learning based system, because then you end up in a vicious circle, testing something that is unreliable with something that is unreliable. So therefore, there you need to go to the other world, to the other side, and use some classical methods. There's also classical AI, right? Reasoning-based methods, knowledge-based methods that can hopefully then identify errors in the models and avoid misbehavior.
Is there a communication gap between both worlds? Because every month, every week, I see a new robotics foundation model. Every university now builds a new foundation foundation model on robotics, Toyota, and in the USA, a lot of companies are working on this. In Amsterdam, and you are also working maybe on a foundation model. But do these people talk to the safety people?
I don't think so, actually. So, and what's even worse, I think, not even the machine learning people talk to the knowledge-based reasoning people. There is some efforts that try to rediscover these communication channels, but it's actually missing. So from cognitive science, we know that a system should have both worlds embedded into the reasoning environment. So there should be a fast system, right, for recalling information that it learned through, let's say, a large language model. And there should be a slow system that identifies errors and fixes them. And then there needs to be something in the middle which mediates between them, and this is what humans call metacognition. But we are not far away from that, actually.
Your safety developers, do they talk to your machine learning developers?
Yeah, the communication is very tight, and I think both from the development community that are also in the large worlds of, you talked about the universities bringing in new.
What is your opinion on these models all around the world?
I think it's amazing, right? It unlocks so many new things that we can do with robots. It solves some of those fundamental gaps that robots have been struggling with forever, which is handling the variety that the real world faces. So there's no doubt there's some like unique classes of applications that really benefits even today from something like logistics, where everything you handle is different. Like every parcel that flows through logistics is basically different. And foundational models are brilliant at that. Accuracy requirements is modest, right? But variability capabilities are extreme. So these kind of innovations makes automations within logistics grow exponentially faster than any other business at the moment. So all of this is great, and for there we're having some quite close dialogues with the adopters of these kind of systems and safety. I think the good thing in my mind is that it does not have to be that closely related just yet, because deploying, automating logistics handling processes using Gen AI has the exact same safety requirement as the other robot application. Right? Because of course motions will be unpredictable, they will depend on whatever the Gen AI model produces. But in the end, it's all about keeping environment and equipment and especially people safe. And we have well-existing technologies for that. We have well-existing technologies for managing motions, also keeping it within safety envelopes of the systems and so on. And we appreciate having even fully dynamic applications in this way. So I think there's some good dialogues going. I agree that having then fully safety-rated models that can predict how to pick up a parcel and do that in a fully safety-rated way where everything is predictable is something else. But I also don't necessarily think we need to slow down innovation and adoption of these models to solve that problem just yet, because they're still safe in the way we do them today.
I was very happy when I checked the agenda of this day because I saw your name, and I did a recording, I think 2 weeks back, with Dennis Stogel. He's a ROS guy, and he was in Odense at the ROSCon, and then we discussed one topic, and I need to ask you this question because I do not understand what you are doing there. Because you showed there a cobot, and you then put a GPU next to the cobot. Does that make sense? Put a GPU next to a cobot.
It absolutely does.
Yes, why?
To basically stimulate the growth we just talked about, right? There's a lot of opportunities that modern AI can unlock across a lot of industries, and we are even seeing it today. I think today 89% of manufacturing
But it's all about cost, right? GPU costs a lot. When I talk to guys who sell robots, they say, oh, in the moment the companies are buying Chinese robots because they are cheap. They buy this for 3 years, and after 3 years they put it on the trash and say, oh, we will buy the new one. But that's a cost topic, right? A GPU.
GPU is a cost topic. There's no doubt about that. And with the advent of modern GPUs, it's costly equipment. On the other hand, I think what really matters is total cost of deployment. Like earlier today, we talked about the key barriers of adopting more automation is reducing overall deployment costs. At the same time, we need to have more flexibility. We need to have better reliability. We need more performance. And we need things that are easier to use. Modern AI solves most of those things. There's no doubt that some of the hardware might be more expensive, but also we know that some of the key cost drivers of deploying automation is labor. It's integration labor, it's technical problems, it's programming time, it's deployment time. All of that with the advent of Gen AI and so on can move us so much more in the direction of deploying things faster, having it run more reliable, delivering more end customer value because of flexibility. So I don't think we should be obsessed about the price tag of individual hardware components. We should think about what would total deployment cost actually be, operational cost over lifetime, and so on.
That's difficult in the moment to argue, right?
Well, I don't know, because in the end, even for a manufacturing customer, they do not see the bill of material to whatever they buy. They see the end turnkey solution cost. And if that's realized with a single robot and a GPU, or if it's realized with a robot and 9,000 hours of manual labor and programming and deployment time, well, for them, it actually doesn't matter. They don't become happier customers if they pay a lot of sort of bespoke engineering hours. So, but of course, it's all about value. It's all about it needs to provide the value to customers. And at least we see it today that some of the things, like logistics, automating logistics would be entirely impossible at the scale that we're seeing it happening at the moment without accelerated computing.
Daniel, does it make sense?
Yes, I think so. So, I mean, consider that. You want to have your models trained in the cloud and you want to have an edge to just recall what you learned, right? So therefore, I don't think that you have just one GPU for one robot, but eventually you will have several, right? So it makes a lot of sense.
Mm-hmm. What is your opinion?
I mean, I tend to agree. It also depends on the size of the GPU. So, I mean, with like the integration still rising, those things will be cheaper as well. So if you now have a prototype with a GPU.
But from my point of view, the time of scaling, it comes at the end when it comes to models or large language models. What is your opinion on that? Maybe we should focus on smaller models, on more precise models, on more domain-specific models, which do not need a GPU, maybe.
Yeah, I'm an advocate for that. So you should not have always the need for an end-to-end model, right? I think that skill-based programming is still a valuable approach for industrial manufacturing. So, and one of the skills may very well be a model, either a VLM, a LLM, a foundation model, and doing a very specific task. And then on the other hand, you may also have good old-fashioned engineering as another sequence, as another skill.
Does AI help us or your community to improve safety or to find new approaches when it comes to safety?
That's a tough one. Improve safety, I think it's still underused to that end. So I think it could improve safety because it just helps us to keep an overlook on all the complex things. I mean, if you've ever seen a GSN tree for person detection, which would cover, I think, the entire wall here, then it's very difficult for us to even understand and grasp all the details. So there it can definitely help. I'm not sure if this is already used on a broad level just yet. Whether it can find new approaches.
Improve, help, develop.
Improve and help, definitely develop. I mean, it also it would need to surprise us because in the end, safety is also about getting acceptance from someone, like demonstrating that the freedom of unnecessary risk. So yeah, maybe a bit philosophical in the end. I'm not so sure.
Anders, what's your opinion on that?
No, I think it does. There's no doubt that the community, both on the advancement that happens in AI, sparks a lot of need for safety innovation. I do believe they can be treated independently. You need to also, from the safety community, think about what does it take to embrace the advances in technology, all the sort of flexibility requirements that comes from AI. And so today it's not about hardening the systems we already have. It's all about how do we work with a structured way of risk and solving the flexibility problems that AI systems inherently will impose to us. And I think that's a challenge that we in the safety community need to accept and think creatively around how to offer new generation solutions, how to manage this, which is often maybe a deeper integration of safety technologies. It's a combination of safety technologies, and it should certainly not slow down the pace of innovation that happens in the AI communities.
Because, I mean, after a short while of thinking, sometimes I think it could help in maybe even re-establishing some things that are already there. Because for a long time, I think safety, especially research and safety engineering, was quite ahead of what is applied in the real world, and some of the methods never really made it into practice because of different reasons, like interfacing of things and so forth. You already said dynamic management of safety instances, for example, and we might see a resurgence of things that are already developed to some degree, but now being applied because there's a necessity. So in that sense, it might actually help us to unlock new capabilities in the safety engineering sense, because we now finally have a way to apply them.
You want to add something, Daniel?
It's the same actually with the old-fashioned AI. Knowing that we have flaws with the new generation of AI, with the generative models, we will resort back to them at some point as well as a companion to the new AI wave.
Today we heard something about safety pipelines. We need to establish safety pipelines. I think the guy from Bosch spoke about safety pipelines, that you always have to reassure that your product is still safe. We know that from a machine learning pipeline, a model pipeline, DevOps pipeline, security pipeline. Is there a new market emerging to build infrastructure for all these pipelines? And who builds these pipelines? Is it who builds this pipeline to the customer? Who will do that?
That's a really, really good question. And there's no doubt that individual products need to maintain safety. And both with the velocity of product development happening, then finding even more structured ways to do safety qualification, safety validation is a need. So speeding up time to market and safety product development is by no means a thing that we have well under control today. I think time to market in general and safety products are probably too long to keep up with the innovation that happens in other places.
But your customer will ask you.
Absolutely. So it is a problem in the safety technology community that needs to be addressed. Like how do we bring safety rated product to market faster? How can we solve some of these things and maybe reduce the reliance on more sort of manual processes and deep technology reviews? And I think that's what automated pipelines brings. If you think about classical software engineering, automated pipelines brings automated robustness. It brings sort of early detection fast. And in these cases, using these more actively and also safety product development would at least be an important both for evolution of products, to have a more software-centric way of thinking about safety products, because software products do evolve. Software products needs continuous integration and test, and hopefully it would accelerate time to market as well.
Maybe there are new competitors on the horizon. When it comes to infrastructure, I know a lot US companies were really looking forward to build infrastructure in industrial environments. So what is your opinion on safety pipelines? And is there an emerging market for that?
Maybe not a market, I would say, but from my research point of view, there's a need for automated pipelines that react really quick. So we need to reduce also the reactivity time. Think about that. Space robotics. There is a robot maybe in a space station orbiting Mars, 40 minutes away from communication to Earth. If something happens, there's no room for waiting for a human to give some advice, right? So the system needs to be in the pipeline, react autonomously, and make decisions itself.
What is your opinion, Carsten? Are you sure that the robotics companies can build these safety pipelines?
I see no reason why they shouldn't be able to. I think the main challenge right now is that a lot of the assurance processes, as already said, are manual labor, and it's very difficult to integrate them into a sort of like DevOps like pipeline. I mean, the process is then just as good as the test cases that you have, and I think there's an ongoing debate in a lot of standardization groups what those test cases, limits, and so forth should be. And until then, also maybe with the idea of getting quicker to market, we have to rely on, I would say, a good sense of human intuition, what should be safe and not, and arguing also not just quantitative in terms of like test case performance, but also qualitative properties. And that is difficult to automate. Eventually, we will get there, but I don't see this happening in the next 5 years.
So you need to invest in this topic.
Yeah, maybe very well so, yeah.
So it's a platform strategy, right? So everybody wants to build a platform. Maybe that's the key to get everybody on the platform.
Absolutely. I think the key value drivers on platform is to be solving real problems.
Mm-hmm. And that's a huge problem.
It is a huge problem. Yeah. So, yeah.
You mentioned smaller models. You mentioned transformer architecture. I'm a bit biased because I work for NXAI and we talk about XLSDM and stuff like that. And do we need new AI architectures?
I don't think they would hurt. Variety is good, I think. And the question is whether they would, even though they are new, what kind of new qualities would they bring to the table? So is there anything fundamentally better or worse? I mean, in the story that I told about the transformer and then a lot of the other things, the takeaway for vision at least was that it's not necessarily the architecture, but some training tricks or some pre-processing stuff that you apply. And I think this is difficult to disentangle, but I definitely think that there are a lot of problems that we are not very good at modeling right now. And one thing that I would like to see, I hinted at this earlier, is not post-hoc explainability, but some sort of interpretability by design. But as soon as you open that box, it's a lot of engineering again. And I've already been told by other people, this is what we did 20 years ago, and that's not modern anymore. You train end to end, and it's a bit against the stream, but I'm completely on your side when it comes to maybe smaller models.
Daniel.
Yes, I think that there is a need for different kind of AI models for actually cognitive architectures. Okay. So also this should have a revival, because if you think about humanoid robots, right, they should react as you expect a human to react on a certain issue. Just repeating what the robot did, if there's an error, may actually not help, right? If you have an end-to-end model, and this is the only policy that was learned, try again, it will not fulfill the task.
Yeah, at least I very much agree there. I think a key criteria for industrial applications is that it has some level of optimizability, that you can also investigate and see, at least grasp some amount of understanding of the fundamentals of the process. So I think for a successful sort of scalable adoption in industry, at least it's important to think about hierarchical models, or at least models that represent different elements which you can go in, you can actually introspect. So I do believe like end-to-end learning will have a difficult terms in industrial applications, where there will be a need of understanding, to refining parameters, to refine at least elements of the process, to optimize. If you're not satisfied with the results, what do you do? That's a fundamental question you need to understand, and retraining and hoping that you get something better, it may not be the answer. So smaller models focus on sort of fundamental building block models and composing them, which is very similar to how humans do as well.
Do we will see a revival of reinforcement learning in the next years? Because in the moment, but only a few people are talking about reinforcement learning.
I think you will have a combination of reinforcement learning and foundation models. Imagine that a robot needs to traverse a certain area that it is not able to even know if it can traverse it, so it needs to try out first. We don't want it to try out in reality because it will topple over, right? So therefore, it learns in simulation through reinforcement learning, generates a new policy that is then fed into the foundation model, and now the foundation model is smarter than before.
What's your opinion?
I mean, I think it even depends on where you apply reinforcement learning. When you mentioned there's currently maybe not so much of a hype, if I remember correctly, a lot of the fine-tuning of LLMs is based on reinforcement learning with human feedback. Yeah. So I think that reinforcement learning has...
Let's call it traditional reinforcement learning.
You mean for control tasks?
Yeah, control tasks, yeah.
Yeah, I mean, we kind of disentangled a bit the sort of training and the deployment. So you can train a action decision model basically with reinforcement learning, but you don't retrain it in practice. And I think this is just learning an optimized policy basically that you deploy. This is also, I think, fine. Reinforcement learning that is still learning in the field, I have to look at the people who would need to work with that, and I usually get an uneasy look back. Mm-hmm. So that is why doubtful.
Let's talk about your safety community, I would call it. Do you need new skills in this safety community? Which skills?
Communication skills, potentially.
Okay. I was surprised how many people came up here and asked questions. So communication is quite good.
No, not in terms of asking questions. But I mean, I still think that there is this natural divide between machine learning people and safety people. And the unfortunate thing is, I mean, both of them have to learn communication skills, by the way. So this doesn't only apply to, but how to learn how to talk to each other, because sometimes they use the same words but with a very different meaning, and then end up in a discussion about the meaning of those words and not what they really want to talk about. So I think for both sides it would make sense to understand a bit better what the other side is about. So what machine learning means and what the impact on the safety argumentation is in terms of, instead of just saying I need 99.999% and please also demonstrate how you do it. Yeah, deliver. On the other hand side, I also think that getting a bit more into the safety mindset and not just thinking about optimizing a large model also helps machine learning engineers to actually develop better solutions, because we don't care about the model, we care about the function in the end.
What is your opinion? New skills?
I do believe collaboration skills is a good term. And I think you presented it very well earlier today, thinking about we have two communities. And we have very modest crosstalk across those communities. But essentially, we should be solving the same problem. We should all be striving for getting more robotics, getting more automation, getting more modern technologies helped to deploy it to help drive society where it needs to go. It needs innovation thinking on safety. It needs innovation thinking on AI. And we're all sort of in that same boat, right? We're not in two different boats sailing in two different directions. So somehow embracing that problem and challenge across communities and actually trying to dive in and sort of combine and compose skill sets rather than sort of pulling in two different directions, which essentially leaves us at the exact same point, right? I think that's the challenge that our community needs, that we actually jump in, and it's a strong point we have. It's a strong point we have in Europe, where we have deep understanding on safety technologies. We have deep sort of automation, application, domain expertise. So we also need to somehow join forces there and drive that forward together.
New skills?
New skills are good, but we should not forget about the old skills. So with ChatGPT, people do no longer learn to program. People do no longer learn to solve inverse kinematics, forwards kinematics, right? The 101 of robotics, this needs to be in the curriculum of any study, I think, for robotics. And for safety, I think it's the same, right? There are skills that you just need, and you do not learn them if you just type a prompt into a API.
At the end, I want all of you to ask, what surprised you today most? Which quote and why? Or which fact or which data or which figure? What surprised you most?
So Anders said that there's only 2% of all the tasks automated today. This surprised me a lot.
That was your presentation, right, Anders? Carsten?
Yeah, same here, I would say. And then follow up, it was more of a question-related topic. The whole security does not work by obscurity, but safety, unfortunately, still has maybe a sharing challenge ahead, and that we may have to rethink how we deal with safety and what can we share and what should we collaborate on.
Anders?
Yeah, I think for me it was a broad conclusion. I had two main observations. I think one of them is I was surprised in the presentation we had from Bosch on how dominant certifications and legislation is in the autonomous driving or across automotive in general, because I do fear that would be an obstacle for innovation. The other thing I realized is a bit of this divide that we've been talking about, that there's only a modest amount of discussion around how to solve big and important societal problems when we are discussing adoption and AI, the divide in between. That doesn't seem to be the main conversational driver, which is, in my mind, a bit of a shame.
I was surprised by the figure that China is pushing safety and regulation, so enormous push from China and Asia. What is your opinion on that at the end, Daniel?
I was surprised, and I actually don't think it is what we see there, because there's so many products, especially robotics products, used in production in China that I think actually have a lower certification rate than what we are used to in Europe, right? So I don't know how these two things work together.
Carsten, do you have any idea?
Maybe they are trying to do the inverse EU AI Act and kind of like motivate local suppliers to provide better quality, at least as a long-term goal. I'm not sure, but this might be one direction. So that's not necessarily about their own market, but to kind of like take away the potential leading edge of other markets in that end.
You sell robots in China?
Oh, yeah.
Difficult?
I think I have a colleague that said it well. The Olympics in robotics at the moment is played out in China. Okay. So if you need to learn how to win, that's where the game is. Okay. It's where half of the world robotic market is today. And there's no doubt it's a tough market with a lot of different driving factors.
What about the safety regulation topics?
I think similar to what we talked about in the domain of robotics, it has been, let's call it, a little bit more loose and now slowly starting to move towards something that we see being more and more familiar to Western standards in terms of safety. It's interesting that it seems to be the opposite driving factors inside sort of automotive. I'm not sure what the key driving factors is, if it's actually a way to try to consolidate the industry and raise the sort of the quality standards, improve exportability, or what the key drivers is. But it's an interesting trend.
Thank you very much, Carsten. It was a pleasure to talk to you about safety and AI. Thanks a lot.
Thank you as well. My pleasure.
Daniel, thank you very much for your discussion on AI foundation models and safety. And thank you very much for explaining me GPUs on cobots. Anas, it was a pleasure.
You're very welcome. Thank you so much.
Thanks a lot. Thank you.
Thank you.